In this video, we're going to talk about how we can make decisions in code to determine whether or not to turn on this light based on whether this button is pressed. So in all of our previous programs that we've written, our program has done the same thing kind of throughout. It just kind of keeps looping through and performing the same stuff over and over again. And ours is still going to loop through in the same fashion, but what we're going to talk about is how we can decide and make branches in our program to have it go one route or another route based on some criteria. And so that criteria is going to build upon what we were talking about last time with the switch, where we can make our program decide whether or not to turn on this light. That's kind of our two branches there, either turn on the light or turn it off, based on whether or not this button is pressed. So let's go through and wire up this light first, and then we will flip over to the code to see how we can get it to work. Okay, so all of our LEDs are going to require, some series resistor in front of it. Either like a 220 ohm or 330 ohm will work well for the 5 volts that our digital outputs put out. So what I'll do is we'll go just from the next pin up, which is pin 3, and go to here. And then what I can do is I will have my series resistor maybe just jump across here. So it'll flow through here, through my series resistor to my LED. And then I want to plug my long leg of my LED into where the series resistor is. And then this won't light up because I haven't completed my circuit here. I don't have a complete path back to ground or what is my 0 volts reference here. And so what I need to do is connect this back to ground. So I can do that by taking this black wire and plugging it into the other leg of the LED. And then I can either run it all the way over to this other ground pin, or this ground pin is plugged in up here to my switch and I can just connect it there. That would work as well. Just any path back through to ground would work for us. And so this is set up correctly. We have our push button to pin 2 and our LED here to pin 3. Alright, so now let's flip over to our program and code up our connection here to the LED. So first I'm going to define a macro here for my LED, and that's connected to pin 3. And then I need to configure whether it's going to be an input or an output. So I will say pin mode LED, and this is an output because we are driving out some voltage to turn it on, or turning off that voltage to turn off the LED. And then our code to turn on an LED is to use digital write to control that digital output, and then we give it the pin number, and so that's LED. And then we tell it either low or high to turn it on or off. So if I say high, what that corresponds to is turning on the LED. So right now this program would just run it would first run our setup, right? And then it would run through loop. So it would run each of these 3 lines of code, then it would be done and run back up to the top and run through these 3 lines of code again. So it's gonna print the state of my button here, right? Whether it's on or off. But it's just going to turn on the LED and keep it on constantly. So what we need to talk about are these conditional statements that are going to allow us to decide, whether or not to run some line of code or which line of code to run. And so what a conditional statement looks like is something like this. So this is not a completed one, but this gives us a general idea of the format. We have the word if here, which helps indicate, we're trying to determine if we're going to run some code. And then inside of here, we put something called the condition. All right, so this isn't actual code. I'm just labeling it in here. This is something that is going to determine whether or not we're going to run this line of code. So there are 2 options here. It's either going to do it or it's not going to do it. And so that, in my mind, is something called a Boolean expression. And what that means is it's something that is either true or false. And so inside of here, we put some statement, and if it's true, it's going to come down here and it's going to perform the code that's inside of here, like some action that is inside between these 2 curly braces here. If this condition here computes to false, it's not going to perform this action. It's just going to skip over it. And that is kind of the crux of what we're going to try to leverage here. We're going to say, if the button is pressed, turn on the LED here. So we need to talk about how we can create this expression, and then the action that we want to do is just this line of code here. So I could copy this here or cut it and then paste it right inside of here. So this is the action we want to do inside of there. And you can see every time we open a new curly brace inside of a programming language, it's going to indent for us. And that just helps us visually see what code is going to run together. And we typically call these blocks of code because these are like the smallest chunks of code that are always going to execute together. So everything in this if statement would run together, right? I could have other lines of code in here, like I could say serial.println, the LED is on, if I wanted just to add another line of code. These two things are always going to run together, and they're going to run based on whether or not this condition is true. So let's talk about how we can construct this condition. It's going to be some Boolean expression that is going to equate to either true or false. And so the way that we read our button is right here. We were able to say digital read to read in the state of that digital input, and the pin that we want to read is button. So I could start by copying and pasting this here into my condition. But we're not quite done. Digital read button, that gives us back some value that's either low or high based on the state of the button. So remember, low corresponds to the button being pressed, and high corresponds to the button being released. And so if I want to say, hey, does this equal high or does this equal low, this is what I would do. So in this case, we're asking, does it equal low? Because when it's low, we want to turn on the light here. So this is the programming way of asking, does this thing equal this other thing? We use two equal signs here. Now it's important to note that this is distinctly different from this single equal sign here. When I use this single equal sign, that means that this is the assignment operator. So it's taking what is on the right-hand side and assigning it to the variable on the left-hand side. This is not doing an assignment. This is just saying, hey, true or false, does this value on the left-hand side equal the value on the right-hand side? So if I read the button and its value is low, what will happen is the Arduino will execute the code in between here. If it reads the button and it's high, which does not equal low, it's just going to skip over this and not do it. So let's upload this program here. Oh, I guess I should try to write my functions correctly. So it's pin all lowercase, and then all subsequent words start with one uppercase letter. So now, there we go. Okay, so if I go back to my serial monitor, I should still see that it's printing the zeros and ones because this code is outside of the if statement there. It's going to continue to run over and over and over again. So it's saying 1 because it's not pressed. And if let's see, go like this, and let's bring this over here a little bit so we can see both of these things. Right, so nothing's happening. The light's not on because this value over here is 1. I haven't pressed it. And remember, 1 corresponds to high, where 0 corresponds to low. So once I press it, we should see this button, or this number, go to 0, and we should see the light turn on. So let's see if it works. Hey, look at that. And then it says our message there that the LED is on. But the second I release it, it no longer says this message. But the problem is our light is still on at this point, right? Because once I pressed it and I turned it on, I don't have anything else to turn it off. So it still only prints that message there while I'm pressing my button, but this light is still on. So we need to add another conditional statement here to say, if I'm not pressing this button, let's turn off that light. And so let's go through that process now, right? So our other condition could just be, if we read this button and it equals high, then do the opposite thing. So if I copy and paste this here, and I say, all right, if I read the button and it equals high, meaning that it's released, then what I want to do is I want to turn off the LED. So I need to set it to low, and that's turning off the LED. And then I could send another message here that says the LED is off. All right, so let's upload this program and click over to our serial monitor, get rid of those. And so it's saying the LED is off because it's going inside of this if statement here. I'm not pressing anything, so it is reading a state of high, and it's printing that value 1, which corresponds to high, and it's printing this message because it's entering inside of this branch of our program. So our program can branch off in these two different directions. It's either going to be low or high. Those are the two possible states for the button. So now when I press it, it's on, and it starts to print to say that it's on, and when I release it, it's off. So we can see now it's kind of going back and forth here. So I want to show one last thing here before we close. Here in this program, I have, there's only two possible states for this digital read button. So if I'm saying, either this is going to happen or this is going to happen, there's an easier way of writing that in code. And what I could do is replace this whole part here with just an else statement. So this is my if statement, this is my else statement. What an else statement means is if the if statement wasn't true, it's going to go in and perform this action. So this should essentially be the exact same program. It's going to have the exact same functionality. It's just written in a slightly different way, and in a way that's a little bit simpler because we don't have to write out a whole condition. So an else statement can't have a condition, but it also can't stand on its own. We had that if statement just standing on its own. An else statement must be paired with an if statement because there's no condition here. So what an else statement means is that, if this statement here was false, it's going to go in and then perform this here. So one of those two options is going to be performed. Which option is performed is based on just this condition here. So if it's true, it's this. If it's false, it's there. So let's just upload it and, to kind of prove that it works the exact same way. So when I'm not pressing it, it should be just saying, 1, the LED is off. And then when I press it, it should say 0, the LED is on, and it comes on. And we see that it's working in the exact same fashion. So that is our basic conditional statements here. We have an if statement where we write some condition, and if it's true, it performs the action. And then we have an else statement, which can be tied with the if statement and will only be performed if the condition inside of the if statement is false.